So let's kind of review where we left off, and then get back into new stuff. I'll tell you what. I feel nice. We'll go ahead and make it. I'm sorry. Who said they weren't here? Oh, so the quiz will be Thursday. All right. Okay.
What about Friday?
Nope. It's not a negotiation. You really want to push it? I didn't want to do that. You just shut up about it now that I did that. Huh?
Choose to my friend Benjamin.
Then you'd have 100 less, and I'd have 100 more, and the quiz would be So, I think we just barely got into, well, I think we finished shading for lines, right? So for example, a real quick example of that, if I had 2x plus 3y is greater than or equal to, what do you want to say, Jeff? 9. What do you want there?
Oh, 17.
You don't want that.
Okay.
Can you everybody see why I put 9? Because eventually I'm going to have to divide by 3, so I put something multiple of 3. And why am I saying that? What do I want to do with this so I can graph this slope? Intercept 4. How do I get there? Subtract 2x. All right, I of course force that guy in there. Divide by 3. All right. Is everybody? You guys with me? All right. You're all paying attention, but I appreciate that. All right. So what can you tell me about that line? The line and the shading is going to be determined by this, and also what kind of line it is. What kind of line is going to be? It could either be solid, dotted. People that say straight, I love you. I still do. Dash it, yeah. So let's see, what can you tell me about this line?
So y-intercept is 3.
Who is it?
3.
0, 3?
0.
Yeah, 0, 3. Whatever, Jeff. And slope is
Down
to
Over 3.
over 3. Kick ass, so down 2 over 3. What kind of line is this going to be?
Solid.
Yeah, I see a line, so I'm going to make a line. Look. Right? Solid line. Let's see if I can. No.
So quick.
There we go.
Yep.
Okay. And then how do I tell which way to shade? What's the textbook way to do it? What can I use? What point? 0, 0. Is 0 bigger than or equal to 0 plus 3? I just put a 0, 0 in.
No.
Is this true? Is 0 bigger than 3? No. So then that means this side doesn't work. So that side works. It's really up to you, but I'm trying to get you used to the arrows because eventually we are going to do multiple lines. And so if you do the arrows, then it's easier. Then you can just darken in where the 2 arrows meet. So eventually we're going to do 2, and where the answer is going to be is where the shading of both overlaps. So it's just easier to put the arrows instead of a bunch of spaghetti. Okay. Anybody else? I'm just hungry.
Hungry for knowledge?
Anything else from that? Hungry for spaghetti.
Okay. So pretty hungry comes to play with this.
All right, guys. Anything about that?
So with that, with what you were, so whenever the when you get to the intersection, wherever the arrows meet each other is where you shade.
Yeah, don't worry about that yet. That's coming. It's coming relatively soon, but it ain't here yet, so let's not worry about it.
I didn't understand the last part of that. I didn't understand the last part of that. How do you find which way the arrows are going?
So, one way is, now, I really want this to make sense. It's exactly the same thing as in one dimension. If I wanted to graph something, I would put the point, and then one side is all answers, and the other side is not answers. So we kind of know shortcuts. Greater than I'm going to shade up. But really, why? Because 3 works. So that side is all answers. Right? And the 2 needs that guy. Right? And this side is not answers. So if I pick one side of the dividing point or line, and that point works, that whole side works. Because this is the dividing line between answers and not answers.
Oh, so zeros, since zero.
0, 0 is just a very useful point to use. I can't use it if the line goes through it, but then I use 1, 0, 0, 1 or something.
If it was -1, then you could use it, or anything below.
Anything that's definitely on one side or the other of the line.
Yeah.
So then you can tell. So if I plug any point, it doesn't matter what point you pick. So if I put in the point 2, 4, what's going to happen with that point when I plug it in? It's going to work.
Yeah.
It's going to gross with the thirds. So that's why we use 0, 0, because then even if there's a fraction here, it's going to die. It's the most useful test point. So you guys, so just like this, it's exactly like this, just in more dimensions. This is how we cut things in half, and then one side is answers and the other side is not. So I just have to check one point. If it works, shade where that point is. If it don't work, shade away from where that point is. Yes, no, maybe, not really.
So if it was like negative, so if it was
I
like.
can't see it.
So if it was like -1 over -2, that would, because.
I'm not sure what that means.
The slope, like if I put.
Slope has nothing to do with the question, the conversation.
Not
that
the-
we're in.
Yeah, the grading, I mean, like is it true that -1 over, not over, -1 and -2 graphed on there would not work?
Yeah, so the point -1, -2 would not work because it's on the not answer side.
Yeah.
Yeah, I like it. So it's like Jets fans and Giants fans, or something, whatever works.
Terrible.
You got that one guy that might be next over here, but then they throw him, yeah, or not. If you don't like football, yeah, it's fine. Is that all right? You guys all right?
I can use like a good metaphor now, like a different metaphor for Giants fans. I don't know what the other one
All right,
is.
I'll work on it if I remember. So now I can't get it out of my head. Stop. So now we're going to get into chapter 5. And all chapter 5 is, this is kind of nifty. I've been trying to get you ready for 5 for the longest time. So what is it about this thing here? How many answers does that thing have? Infinite number. Any value you pick for x, there's going to be a value for y. It's got an infinite number of answers, right? And what about this one? How many answers are there? Huh? Infinite. All right, now. Did I pick some that are kind of gross? Yeah, I did. Let me try. So, if I have one line, it's got an infinite. Let me just make this nice for a couple ways. X plus y equals 6, and then x minus y equals 2. Both of these have infinite number of answers. When I plot them, if I plotted this one, what does it mean when I connect the dots, when I make the line? What is that? This is a weird question, but what does that really mean? What am I really doing?
Every point on that line makes you
Yeah.
true.
So it's the quickest way to answer what are the answers to this. Well, just get whatever point you want to on this line I just made. Any point on that line answers this. So if I graph this dude and graph this guy on the same graph, where would the point be that answers both of them? Where these two do what? Where they intersect. Because in order to be a true, make the equation true, the point's got to be on the line. So if these two lines meet at one point, that point is the only point that makes both of them true at the same time. So really, this is sort of like me saying, you add two numbers together, you get 6. If you subtract those same numbers, you get 2. That's not really hard. Can you guys figure out what the numbers are? Two numbers you add to get 6, but when you subtract them, you get 2. 4 and 2, right?
Yeah.
Is that cool? That one's easy because it weren't like coefficients. It was just straight up add numbers, subtract numbers. So you can kind of think about it. So the answer should be 4, 2, right? All right, so take a minute and graph both of these. Actually, let's do this a little bit together because there's something I want you guys to get used to. What do I have to do first to start to move towards graphing this guy?
Subtract that.
And
The slope intercept. So subtract x, make it a slope intercept. So there's the first one. And this one, I think, remember, I've shown you guys this trick a few times, but you always forget about it. That kicks so much ass. Just put the y over there, put the 2 over there, so y equals x minus 2. Or you can do it the long way, doesn't matter. So that's the second. So here's what's really cool. If I ask you to solve, don't write this down, but if I ask you to solve some equation with just one variable in it, that's all. You just need that one equation. You can solve for x. Because there's one thing I don't know, and I told you one piece of information.
So the thing that confused me was the x minus y. So if it's like that, and you have to add, x over there, you take the negative sign and you.
All right, now watch. So if I do this the long way, I would subtract x. Is that cool?
Yeah.
Then I would divide by -1.
Okay.
So that would become positive x minus 2.
Oh.
Yeah. The shortcut just makes the y positive and brings the 2 over, so it's quicker.
No.
Yeah. All right. Let me say this again. This is really cool. I have one thing I don't know. I need one piece of information. So if you didn't know how old I was, but then I told you what year I was born and what month I was born, then you can figure it out. Right? So one piece of information, your birth date, and then you can figure out my age. Right? If there are 2 things I don't know, I need 2 pieces of information to figure that out. So it feels like a murder mystery, right? So what are you trying to do when you're trying to solve a murder? How many unknowns are there? There could be quite a few unknowns. So the more unknowns there are, the more information you need to kind of tie things together.
So I can
Yes.
figure out since you told us that you did part-time work when you were 16 in the 80s. If I did all of those.
Yeah. You can estimate my age, but maybe not to get it exactly right.
Yeah.
But anyway, we don't have to sleuth that. All right, so we already know the answer to this question, but if I graph these, they're going to meet at 4, 2, because that's the point that makes them both work. There is no other point that makes them both work. It's impossible, because of the fact that they're both straight lines, there's no way they can curve back and hit each other again. Right? Unlike the street in Virginia where it intersected with itself, which is always the corner of the street and itself. So let's see what happens if we plot these suckers. So what's the first one? This intercept is off my graph. 0.6. And then I'm going to go
Down 1 over 1.
down 1 over 1. So I'm going to go down 1 over 1, down 1 over 1. I've done this before. I didn't really need to, but now you need to. Because if I just draw 2 lines and I'm like, where do they meet? Shit, they're probably not straight. Even if you make them straight, your scale's probably not perfect. So you'll see in a minute why I'm going to do this. You want to do this when you do this kind of problem graphically. Down 1 over 1, down 1 over 1. Did I do that right? You come this way. No, I sort of messed that up. I got to look at it straight. Down 1 over 1, pop, down 1 over 1, pop, down 1 over 1, pop. All right. So there's that one. Yay! Now, the other one, x minus 2, what do we know about that one?
0, -2.
0, -2. Let me make that a different color, just because. Bob Ross teaching that. A little green blob lives here.
Up 1 over 1.
Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. What point is that?
4, 2.
4, 2. So if you didn't do that step, it would be really difficult to tell where that meets. If you just kind of drew the lines in, you're like, where the shit is that? But if you step more than you normally would, it'll be easier to see where they both meet. Okay, maybe. I don't know. Look on some of your faces. I'm not really sure how to interpret. So this is the way to solve this thing graphically. Now, why, yes,
On the x-axis, that
Yes.
is 3, right?
what's 3?
Yeah,
Yeah? What's up?
but it's 4/2.
Yeah, it's 4, 2. 1, 2, 3, 4. Yeah, the point where the two lines met is 4, 2, yeah. Okay, I like it. All right. We're gonna do more of this type, but what would the shortcoming of this type be?
You got big numbers. You got big numbers where you got decimals, maybe?
Yes, the answer doesn't have to be nice whole numbers. The answer could be disgusting. So we're eventually gonna create algebraic ways to solve this. Because algebra don't need no precise steps. It can just handle whatever the hell number comes out. So there needs to be an algebraic way to solve these. Some of you guys might already know some of those. There's substitution. There's one called, what I call elimination. Some books calls it addition, which is not as interesting as elimination.
Death match.
Pretty much.
Death math.
I'll allow it.
You got it on video, folks. He'll allow death math.
If you knew the history of math, you can see how appropriate that is. So let's try another one. What if I had this here? Let's see if I can make one that's not too real.
26.
One like this one.
How do you wanna make it so hard?
I don't know.
That's too gross. May not make it too weird. All right. Yeah. Okay. Oh wait. Yeah. Okay. Need a little break. Jeez. So obviously, so we're doing this graphically. So if you know the other ways to do this, you gotta be really careful. In the instructions on a test or in the homework, it's gonna say solve this graphically, and you solve it a different way, you get no points.
I was just thinking, because I was doing homework and you got these two equations, and then they give you like two sets of numbers, and then you just put them in to see if there's a solution or not.
Oh,
Is this
yeah,
kinda
sure.
what we're doing?
Yeah,
Oh,
yeah. Well,
okay.
that's like the first level is
Right.
if you want to test the solution, it's got to work in both. So the first level is always kind of like, can you check an answer? So if I wanted to check the answer, we got 4, 2, I'd plug it in here. Negative 4 plus 6 is 2, and 4 minus 2 is 2. Yay! So I mean, that's just, you got to be careful when you go to check an answer of a system of equations. It's got to work in both, or in all of them. If there were 3 things I didn't know, like X, Y, Z, how many equations would I need? 3, which sometimes maybe is a lot. I don't know. Okay, so do this one real quick.
Okay.
Make sure everybody's on the right track. What do you guys have to do first?
Slope intercept.
Yeah, solve for y, so you can graph the lines. I like it. Some of you guys are freaking me out. You're doing it in your head or something. That's a lot to have in your head. Yeah, cool. I like it. Yeah, the nice thing with this one, these kind is there's no shading. Or, yeah. Alright. And this one you get right? And then one myself, so why would I need to? So basically just change everybody's sign. Yeah.
She usually always gets it right. It's both sided.
It's called Schadenfreude in German. Pleasure at the misfortune of others.
You've been to Germany?
Huh?
You've been to Germany?
Yeah.
I don't know if you like seeing
Oh, yeah. My mom was born in Germany.
Ah.
Gotta know how to cuss in other languages, kids. Just for Scheiße is a big one. There. Learn sign language. This really is. Yes, exactly. That's shit. This is addicting. So in the meeting, I was just going. Very tough. Yeah, I got a headache. Gets a lot of stress out. See if my dean is like, you did that to me once. Yep. All right, let me catch up to you guys a little bit. I just think people make us, I still see people doing stuff when you subtract 3x, that's negative y. But sometimes on the next line, the negative goes away.
This another one?
Hmm?
Another one?
What do you mean? That's this. Same thing, same thing. I'm just solving for y, solving for y.
This one.
I like it. And then when you go to graph this, what do you know about the first one?
This is 0, 0.
Kick ass. So it's like, it looks like there's nothing there, but we know there's an understood plus 0 there. Or now you do. So 0, 0, and then from there I go down 2, over 1, down 2, over 1. I could even go up 2, back 1, up 2,
Yeah.
back 1. All right.
Dip.
What's going on over there? Oh shit, that's a little curvy. Too bad. And then I've got, so that's equation number 1. This guy, the y-intercept,
Zero, negative
number 5, and then I go up
3.
3. 1, 2, 3, over 1, kick ass. All right. So the answer is,
1, negative.
and how do you check that? Plug it in
To both.
both.
Okay.
First try.
So 1, negative 2, so 1 is negative 2, sweet. 1, 3 minus 5 is negative 2, sweet. I like it.
Wait, so you go up 3 over 1?
Yep, up 3 over 1. Whenever you got a whole number, you can put that over 1.
Alright.
Yeah. Can't be over 0, because then that would be freaky. That would be undefined shit there. We don't have a symbol for that. Well, we sort of do. It is October. Weirder things have happened. Okay. I do have a little handout I'm going to give you in a minute. You know me, I think. Let me make sure I don't skip any ideas. No, good. Just a little bit of a algebraic method here. There will be 2 algebraic methods. We'll talk about one of them right now. Substitution. I always felt this was the sneakier one.
Is this really like make the to each other?
No, sort of. You could, but no. All right, guys. So, for example, this is such a cool idea. If I had, let's see, y plus 7x equals 6, and then I tell you that x is negative y. Sure, let's do that.
No, that's good. I didn't say it.
Oh, okay. What's up?
Yeah, it says y equals 3x minus 5. How do we get minus 5 out of 5 divided by?
Okay, so again, I'm doing the shortcut thing. where you can just switch these two, because I would add y, subtract 5. But if you do it the long way, you can subtract 3x. Cool. And this is what I was talking about. Sometimes people forget that negative. Now, how do you get y by itself? I have to divide by negative 1. So that makes it positive 3x minus 5. But the shortcut is add y, subtract 5, bam. The thing I want is negative. So I could kind of eventually divide by negative, but that's easier for me to make mistakes. So I'd rather just add him over, make him positive directly, subtract that dude, bam. And if you don't like that, it still works the other way. It's just easier to make a negative mistake this way. But you just gotta be careful. It still works this way, of course it does. But people forget that negative, or they don't divide everybody by negative. Or some of you guys are dividing by negative and keeping it like this. And then when it's a parallel perpendicular question, it's really weird to try to figure it out. Simplify it all the way down. Kill the negatives. You like it? Okay, anything else about that one before we go back? Okay, now. This one kicks a lot of ass too. So this is 1, 2. So in the second one, I know that x is negative y. I know that's true. So how can I use that in the first guy? Yeah, wherever I see x, and you can see why we call it, because we're very, very creative. Wherever I see x, I substitute it with what it is. X is negative y. So how can I rewrite 1? Y plus 7x, but x is negative y. So y minus 7y equals 6. Negative 6y equals 6. What happened back there?
Sneeze slip.
Yeah, something like that.
Okay. You guys see that? Am I done?
No.
Because what's the answer to a system of equations? It's got to be a point. Because even if I solve it algebraically, it still represents the point where they would meet if I graph them. So the answer's got to be a point. So what do I still need? Yeah, so x is negative y, so x is negative 1, so x is 1. Now this is okay, but how should the answer look? 1, negative 1, yeah. Because again, it is a point. How are we doing? Questions? Huh?
Okay.
So what about, let's see. I want to show you something kind of cool here. Finally, Jeff? Shut up. Alright, let me see. Yuck. Why did I do that to myself? Oh, I see. Yeah, that'll work. Okay. Now, I want to show you this because this is something that gets kind of lost when we show people this. Students get so stuck on trying to solve for one letter and plug it in. Do you see something better up here? What does the first guy tell me for sure is true?
Y is 4 times y.
4y is 3x plus 5. And the whole idea with substitution, is to replace one variable with something to do with the other variable. So overall, like right here, how many variables did I have in here? 1. I had 2y, but they're both 1. I had one variable. What's the problem with these? They have 2 variables. That's why I can't solve either one. But if I use one piece of information with the other one, now I have one variable I can solve. So right here, I know 4y is 3x plus 5. Yeah. So I can replace 4y. So I got 5x plus, well, what's 4y? 4y is 3x plus 5. You guys see that? Both of these equations are true at the same time. I know 4y is that. So wherever I see 4y,
plug it in.
I could put that. Because that's what that says. 4y is this. So if I see 4y, I could write that. And why is that better now? Why is that equation better? There's one variable. I could solve for x then. See if Jeff made a good equation. Yes, he did. Huh?
X is 1, right?
Yeah.
Yeah.
Subtract 5. 5x and 3x is 8x. 13 minus 5 is 8. X is 1. And y would be, how do you figure out what y is? So I can use this one, for example. 4y equals 3 times, get out of there, 1 plus 5. You guys with me? I know that x is 1. So now I can plug 1 back in. It actually could be either one of these. I just picked this one. Plug a 1 in. 4y equals 8.
Yeah.
So y equals 2.
Oh, yeah, 'cause you have to divide.
The easiest thing to forget is you get one variable and you stop because you're used to solving for x and stopping. But you got to remind yourself that the answer to this, there's 2 unknowns, you got to get both of them. So what's another way I can write? So this is acceptable, but how should I write it, of course?
1, 2.
Yeah. Make sure you put that bad boy in the right order. I like it.
Yeah, 'cause I think if you switch them
Be
over.
doing that hereditary shit.
Yes, that's what she was like.
Exactly. If you see a light kind of going around and stuff, just leave.
Don't
Just
take any car rides.
leave. If you didn't see the movie, you're fine.
What movie?
You don't like horror movies, you didn't see that one, I'll tell you that. Alright, come back to me. Come back.
That's what she reminds me of.
I know, me too. I know. That
Is there any
freaky
way-
little thing and the heads go flying and shit, no. Making a little montage.
Flies on the.
Yes?
So, the equation on top of 4y in blue, the equation on top, where did that come from?
Okay, what did we just figure out right here? What did we just figure out?
Yeah,
We know x is 1.
right.
So now I can plug a 1 right there.
Go to the original.
Yeah, I kind of did it in a bad way. Let me do it again over here. Once I know one variable, I now can figure out the other one. So I can plug that. I know x is 1, so now I can take the first one. Oh, let me see if you're. Oh, look. All right. Take the first one. And how can I rewrite this? Well, now I know x is 1.
Right.
And that's why this thing that we just did should not be that big of a deal. I've been doing that shit the whole time. If I know x is 1, I put a 1 in place of x. Well, I know that 4y is this, so I put that in place of 4y. That step should not be that big of a deal, but it's also, you're not used to the fact that you can do that. You don't really see that often enough. That's the full flexibility of this method. So here in place of x, I put 1. You're still not doing good enough for me. And then I just solve. Right? 4y equals 8, y equals 2. Now what if I would have chosen this one instead? So that's 5x, and I know x is 1. Subtract 5, 4y is 8. So y is 2. Still 2. And why should it not matter? Because this is where both lines are supposed to meet. So it doesn't matter which line you plug x into, they're supposed to meet. That's another way to check this. If you plug it into both and you get different answers, you got something wrong somewhere. Demotivational. You got something wrong. Yes.
Here, for y, you get y alone. You don't need to get y alone.
You don't need to, because 4y is there.
So what about if?
4y is this, and I see a 4y. Now, if I didn't see a 4y here, then I would have to solve for y and deal with the fractions. You with me?
Yeah.
And that might happen in a couple problems. But if that would happen, I have a much better way to solve it, not substitution. All right. But I'm not going to show you that method yet, because I want you to get used to substitution. Yes?
Are we getting the handouts right now?
Yes. Okay.
End of question. Oh, I should have said that. God damn.
What?
We gotta rewind. Okay, so Holly asked us a question. Are we getting the handouts now? you answer,
Yes.
okay, no further questions, Your Honor.
You can't handle the math.
Who's the actor that said that?
Jack Nicholson.